All right, today we're going to talk about our polynomial applications. So we're taking what we've learned and putting it into word problems. So let's go ahead and let's get started. A circular walking path has an unknown radius of x feet. If the radius was increased by 5 feet, write an expression that would represent the new circumference. So there's a lot of information in here that you need to know. So first off, it's circular. Now there is no picture provided, so I always like to draw a picture if it fits the situation. So I'm drawing a circle, and then there is a radius. So remember, the radius goes from the center of the circle to the outside, and it can be anywhere. So it could be here, or it could be here, it could be here, whatever. So I just drew a radius from here to here. And it says the radius was increased by 5 feet. So if it was originally x, it was increased by 5. So now this is your new circumference. And then you need to remember the formulas for circumference. So its circumference is pi times diameter. Well, it didn't give us the diameter, so we're going to go, remember that 2 radii equals 1 diameter. So we're going to use this formula. We're going to plug it into here. And so circumference equals 2 pi times, and instead of the radius, we're going to put x plus 5. Now that we have this all set up, we're going to take 2 pi times each term. So 2 pi times x gives you 2 pi x. 2 pi times 5 gives you 2 times 5 is 10, and then pi. And then that's all we need to do for that, because we don't need to combine anymore. So that's your final. So just getting that set up was half the battle of what to figure out what to do. All right, so now, sometimes you have a figure that's made up of more than one shape. So you may need to add or subtract one shape from another to get the area. So here we've got a rectangular parking lot that has a small rectangular area in one corner that needs to be repaired. The dimensions are shown in the drawing. What is the area of the parking lot that does not need repair? So remember, this little bit here needs to be repaired. Oops. So we want to figure out what's the rest of it. So what we can do is we can take the area of the whole rectangle, and then we're going to subtract out the part that needs to be repaired. All right, so first off, remember area is length times width. So now we're going to go through and we're going to take 7x times 13x, and we're going to multiply those together. Or you could do like that, either way works. And then that's going to give you 91x squared, because remember, when you're multiplying the same base, you add the exponent. All right, so that is for the big part. Now we got to find the area of the small part. So that's 2x times x, and that gives you 4x squared. And then remember, since we're taking that away, we need to subtract. So notice they both have the same variable and exponent, so they're like terms. So all we have to do is combine those to get 89, and then bring down your variable and exponent. All right, so this one is kind of the same thing. We just have bigger numbers to deal with, or more terms. So it's a rectangular design that has the dimensions as shown. So if a small area represented by the small, so this guy is removed, what is the remaining area? So we want all of this here, and we don't want that. All right, so what we have to do is we're going to take the area of the big rectangle by multiplying those together, and we're going to subtract it from the area of the little rectangle by multiplying the length and the width together. So remember, when you multiply, you need to distribute. All right, and then here we're going to go x times x, x times 3, 1 times x, and then 1 times 3. And then remember, all of this, you're still taking all of this away from that. So now let's combine our like terms. And then we're going to combine our like terms. And again, this is the big square, or rectangle, excuse me. This is the small rectangle, and we're going to subtract this from that. So remember, when you have this, it's really like a -1. So we're going to distribute the negative to each term. And then now that your parentheses dropped, we've simplified that, we can drop this set of parentheses also, and then start combining like terms. Well, that cancels your x squares out. I've got 12x here, -4x here, so again, like terms we combine. And then I've got 32 and -3, which gives you +29. So this is your final. All right, now for number 4, you're going to try this, but I'm getting you set up for it. So the figure below is made up of 2 rectangles. What is the total area? So remember, in total, you're going to add the 2 areas together. So we're going to make, and you can actually separate this because originally we didn't have this part, but you can make, oops, maybe not that. Okay, there we go, try this again. There you go. So we can make 2 rectangles out of this, and we're going to find the area of the first one. So we've got our length and our width, and then we're going to find the area of this one. We've got a length and a width, so really we don't need this bottom one. That's just extra information. So you can cross that out or just ignore it. And then let's go ahead and let's set up the information together. Or I set up the problem for you. You just have to put the information in. So again, take this, multiply it. And then for this, you take those 2, multiply it, and then add the 2 amounts together. And let's go to the other or to the next problem. So here it says a room has a floor space of 2x squared plus x minus 15. We want to know the dimensions. So if you want to know the dimensions, you want to know what the length and the width are. So we're looking for length and width. All right. So, and to do that, we need to factor. So what we're going to do is we're going to take this and we're going to go a times c. So a times c equals -30, but it needs to add to give you +1. So our factors of 30 we got, but we need a difference of 1. So that doesn't work, that doesn't work, that doesn't work. This one works. Now remember, since this is a +1, your bigger number needs to have the positive. So we've got our numbers here. Now we're going to break apart our middle term to 6x and -5x, or -5x, excuse me. Bring the other parts down. Now we can group. Now that we got this, we're going to group this. They both have 2x in common. And after you divide this by 2x, you're left with x. After you divide this by 2x, you're left with 3. And then now we're going to group this. Now we want to get a plus here, and we have a minus here. So we got to factor out a -5. So when we factor out -5, we're left with x and +3. Now notice, these are exactly the same. So that's one set, and then whatever is outside your parenthesis is the other set. So these are your 2, and it doesn't specify, so one could be length, one could be width, or vice versa. All right, so what you're going to do is you're going to do this problem, but I did start it off for you because there is a GCF. So now what you're going to do is you have a GCF of 2x, so you're just going to leave that. And we're only worried about factoring this part. Just don't forget to bring down the 2x at the end. All right, now let's get into this one. This is a square with an unknown side length of x. So again, draw a picture. And then you have a rectangle that has a side length of 4 feet longer than the square. So if we started with x, where it's 4 feet longer, than the square. And then the width, this is your width, is 2 feet shorter than the square. So the areas of both are equal. We want to find the dimensions, so we need to factor. So the area of this one is x times x, which gives you x squared. And then you're going to take these two and multiply that. So I got x squared, and we're equaling them to each other. And then now, x times x is x squared, 4x, negative 2x, minus 8. Combine like terms, and then bring the rest down. So now we need to move x squared over here, and that actually cancels that out. So I'm left with 0 equals 2x minus 8. I'm going to bring it over here, just so we have a little bit more space. So I'm going to add 8 to both sides. And I've got 8 equals 2x, divide by 2. X equals 4. So now we know the side length of the square. So we know this side is 4, so all the sides are equal to 4. All right, so what I want you to do is you're going to do this one, but you're going to set it up very similar to how this one is. And I'll give you a hint, your answers are 5 and 20, or 5 by 20. So if you did number 8 correctly, that's what you should get. And then that is polynomial applications.